start off, you have to isolate y.
Okay. How about tell me what the slope-intercept form is?
Y equals mx plus b.
Okay, so good. You figured out you got to isolate y, so I got this to start with. How do I isolate y?
You could subtract 8 first.
Okay.
So subtract or add 3x to the other side.
Okay, so that's going to leave y all by itself on the left. What's the other side going to be?
Positive 3x minus 8.
Which answer is that? Good. And read that. Now, if I said to you the following, shaded region problems, which you've probably dealt with in your geometry class this year, shaded region problems are always blank. What kind of problems? Shaded region problems are always blank problems.
Would it be addition or
subtraction?
Subtraction.
Subtraction. In other words, we're always going to take the area of the entire square and subtract out the area of the white portion. This is a little bit of an unusual shaded region problem. Usually shaded region problems are something like this, and you have to figure out this shaded region. So you take the area of the outside circle, subtract the area of the inside circle, and you have the shaded region. But almost never can you figure out shaded region without using subtraction. This actually is one case where you could. You could break this up into a rectangle and a little square and add those two together and figure out the shaded area. But in general, shaded region problems are always subtraction problems. This might be the one exception, although you can certainly do this as a subtraction problem. What is the area? Let's do it as a subtraction problem. What is the area of the square underneath?
Would it be 36?
Yeah, so first of all, let's say the area of the shaded region is equal to the area of the gray square minus what portion of this square are we going to subtract out?
So
1/4.
is that 1/4?
That's 1/4 of that white square. So I'm going to subtract 1/4 the area of the white square. So the area of the shaded region, the area of the gray square is 36, you knew that. What is 1/4 of the area of the white square? Or what's the area of the white square?
1/4 is 36.
Yep. Which is 9, which is 27. Now, I did have a student who tried, I didn't say anything about subtraction, and she solved this perfectly legitimate by breaking it up into a rectangle that was 3 by 6, which is 18, and then this tiny little square right here, which is 3 by 3, so that's 9. So we had 9 plus 18 equals 27. So this may be one of the few shaded area problems I have ever seen that you actually could do without subtraction, that you could do it by addition, by breaking it up. But that's the exception, not the rule. Most shaded area problems you will get will have some sort of a curved surface on them. and making it impossible to figure out the normal way. In other words, if I told you figure out the area of the shaded region, there is no way to do that other than as a subtraction. Let's do this one. Radius is 1. What is the area of the shaded region?
36.
That's the area of the square.
Oh, the shaded region.
Remember, it's always a subtraction problem. So you have to subtract out the circle that's in the middle. That circle has a radius of 1. What is the area of that circle? It's the area of a circle. What's the general equation?
A area is the radius times pi r squared.
Okay, so what's the area of this circle with radius 1?
3.14 times.
Now leave it in pi. Leave it in pi. Don't convert pi. On the ACT test in general, you almost never have to convert pi.
So then it would just be 1.
It would be pi, 1 pi.
Right.
So that would be the area of the shaded region, 36 minus pi. Okay? So that's a more typical shaded region problem that you'll get, because there's only one way to solve that, and that's with using subtraction. We don't have the geometry to solve for this kind of a geometric shape. You know, that's straight lines on the outside and circular on the inside. We don't have any figures that equal that. So the only way to solve this is take the area of the outside square, subtract out the area of the inside circle. Okay? This is a triangle you've probably seen many times. It's a 3, 4, 5. So what they're saying is that there is a similar triangle somewhere. And by similar, it means it's also a right triangle, and whatever that angle is that angle, and whatever that angle is this angle. That's what similar means. It also means that every side of this triangle over here is going to be a certain multiple of this triangle. In other words, if this was 30, that would be 40, that would be 50. Okay? All right. So what they're saying is that the perimeter of this triangle equals 36. What is this side right there?
Would it just be like 3 times?
Good. Why? Because the perimeter of this triangle is 12. So the ratio of the perimeters is the similarity ratio. You've used that term, right, in your geometry class?
Yeah.
Okay, the similarity ratio is the ratio of a particular side to the corresponding side of the triangle that it's similar to. So the fact that the perimeters have a 3-to-1 ratio means that each side has a 3-to-1 ratio. So what is x?
Would it be 9? Or, I'm sorry. Yeah, 9.
Don't apologize when you got the right answer. So that's 9. What's this side down here? What's this side?
15.
Add those up, you get 36. And it's still a 3, 4, 5 triangle. It's just a multiple of a 3, 4, 5 triangle.
Okay.
It's a little different. Medium difficulty, maybe. I don't know that I would say this is hard yet, but what is A plus B equal to?
Maybe 0? I mean, not 0. I don't know actually. Well, 4, if you get 4.
All right, tell me what you're going to do. Tell me what it is and I'll write it down.
Okay, so 4. Bracket A plus B. And then times 20
Very good.
equals 40.
Okay.
So, A plus B has to be a smaller number because 4 times 20 is 80.
Okay, well, let's do it step by step. Don't try to eat the whole cake in one bite. How are we going to solve for A plus B? Your reasoning is absolutely correct, but doesn't help you get the answer. To get the answer, you need to figure out how to solve that algebraic equation. What is the next step?
Would it be
Okay, we're trying to isolate that, right? If we can get that all by itself on one side of the equation, we'll have the answer.
okay, so then would you 4 times 20, would you go to 80 and then subtract 80 to the other side?
Not subtract.
Oh, divide.
Yes, you always have to do the inverse of what's being done. If multiplication is being done, you have to divide. If division is being done, you have to subtract. If addition is being done, you have to if division is being done, you have to multiply. If addition is being done, you have to subtract, and if subtraction is being done, you have to add. So multiplication is being done. So let's divide both sides by 80. So now we have A plus B equals 40 over 80. What is the answer?
The answer will be 0.5, so half.
Good. 25. Go ahead and be reading that while I'm writing it. C is some constant. We don't know what it is yet. In fact, the question they're asking is, what is C? So we have to figure out what C is. So the very last sentence they give you allows us to do what?
Determine.
Yes, definitely can determine C, but what am I going to fill in? I've got 3 variables. I got that, and I got that. Those are my 3 unknowns at this point. Notice they gave me 2 of the 3. Which 2 did they give me?
300 units produced and sold, so that would be X. 300
Yes. Okay. What is 1900 equal to? Okay, P of X. So what can I write? What kind of an equation can I write now?
So then 1,900 times 300.
Hold on, no. That is not multiplication. That means that we have a profit as a function of X. So I could write that as just capital P if I wanted. The fact that they put parentheses X, that only means that everything you find over on the right side of the equation is going to be the variable X. You're not going to find a Y, you're not going to find a Z. You might find the C, but that's a constant. Once we solve this and we figure out what C is, we'll rewrite the profit equation where C will be a number. But when you see this, P of X, that's like F of X. F of X just means Y. It means it's a function of X. Sometimes you'll see G of X. Well, that's not multiplication either. That's a function. We're just going to call it G instead of F. Well, this one, they're just calling it P. P of X. The profit is a function of X is what that means. Okay, so now what's the rest of it I can write?
So then equals, my computer overheated.
What happened?
My computer overheated. It just shut off.
Ah, so you can't see me anymore. You can't see what I'm writing? No, I understand exactly. I have a laptop, and that kept happening to me. I can give you a couple of tips before you get your new laptop what to do. You want to know how to solve it? Put a tray of ice cubes in a plastic baggie and put your laptop on top of that baggie.
Well, that won't hurt it?
Nope. As long as the ice cubes are inside of a plastic baggie, the computer won't be sitting on liquid, it'll be sitting on cold. And it'll keep it from overheating.
Okay. I should definitely do that next time.
Definitely.
I'm sorry. It seems like I always do every single time.
No, that's all right. So you're waiting for it to reboot right now?
I just need a new computer. I've had it for a pretty long time now, so.
Okay. Is your computer that you're using now going to be able to reboot, or is it too hot? Is it you're going to have to wait for a while?
No, it's turned back on right now, but not so preparing.
Why don't you try that? Why don't you go in the kitchen right now, if you can, get some ice cubes, put them inside of a baggie, a plastic bag, and put enough in there that you can build yourself a little pillow of ice so that your laptop can sit on top of it balanced.
Okay.
And that may get us through the session.
The only problem before, I think, was just I kept it on I have a pillow.
Okay, you can't do that. Yeah, that's definitely a no-no. Yeah, that doesn't allow it to breathe. In other words, when you keep it on a soft surface like that, the fans that are blowing air can't blow the air out. And that'll cause it to overheat every time.
Well, now I've moved it to a cold surface.
Okay, or even a flat table, something like that. That should solve the problem.
Okay, it's almost there.
Okay. You'll need the meeting ID number. I haven't logged out, so it's the same as I sent you. Do you still have it on your phone?
Yeah.
Okay.
Yes.
Okay.
Yeah, it's interesting. I just got a new phone today.
Oh, yeah?
Yeah.
What kind did you get?
The new iPhone 5S.
Ah, okay.
It was cool to see because I was trying to figure it out before our session.
Uh-huh.
And your message came through, and I was waiting to see if it, worked. It did, so that was great.
Now, did you have an iPhone before that?
No, I did have an Android.
Oh, did you?
8.
That's what I have as an Android. I have a Motorola Triumph.
It did its service for, the little few years that I had it. But,
Well, there's going to be one very nice thing about your Apple iPhone, and that's that your camera is much better, probably. It's at least 12 megapixels, isn't it?
I think so.
Yeah, see? Yeah, the one you had was what?
It was just really terrible lighting.
Yes. Yes, mine too. You notice how gray these images are? Of course, you're not looking at them yet. But my SAT or the ACT test that I've scanned into my computer, I'm using this 5 megapixel phone, and boy, the lighting sucks, and the resolution isn't very good either. I'm almost embarrassed to use them. But so
I thought that I meant as you took pictures of. Oh well, that makes sense to use your phone.
you know, it's the fastest way for me to get material into my computer. I actually have a scanner that does a pretty good job, but it takes forever. The scanner takes like a minute per page, whereas the phone, boy, you just take a picture, and take another picture, and you can scan like 20 pages in a minute. Yeah, it is. It's a much better way to scan stuff in, but I need a better camera. My 5 megapixel isn't quite good enough. I get these kind of results. Boy, I've been scanning stuff in for 5 years, so I have a giant math library. I just wish I had used a better camera.
Yeah. Well, I tried to go to meetings to start with Lauren. Lauren, she's one of your students.
Yes.
She's having some problems with short geometry.
Uh-huh.
And I actually do understand that pretty well. And that is very easy for me.
Wow.
So I just out through that.
That's cool. So the two of you have go-to-meeting sessions.
Well, we were going to try, but I realized how expensive it was.
Well, yeah, GoToMeeting is $49 a month if you want to host. So I have to pay that, but none of the people joining have to pay it because join GoToMeeting is free. But if you're going to have a GoToMeeting with somebody, somebody has to host. So.
Yeah, and so I decided not to do that. We did it over Skype, which was pretty terrible because
well, now, Skype doesn't give you the capability of having a drawing tablet, does it?
well, it lets you share your screen.
Oh, it does. Skype does. Oh, well, that's changed. In other words, I could use Skype, right?
Yeah, but I feel like I have a lot more problems with Skype. So,
Really? The quality isn't as good? Okay.
But I mean, if you go and look and see, if you try it out, it might work for you.
Huh. Okay.
Right.
Well, oddly enough, it showed you, it must have showed you logging out, and now you're logging back in. Okay.
Yeah, I can see it.
Okay, you can see the screen now? Okay.
Okay, so for that one, would you put 1,900 in place of X?
No,
17?
the profit was 1,900. Notice what they say. The daily profit, P, is given by the function P of X. That means P of X is the profit. So we put 1,900 in for that. What are we going to put in for X?
300. Oh my God.
Still have to solve that for C.
Now it's easier because we only have one variable.
Right. That's the only variable you should be able to solve for. What's that?
0.056.
No, 17 times 300.
Oh, for some reason I almost. 5,100.
Okay. Minus, what's 10 times 300?
Right.
plus C. So we're whittling it down. Now let's remove the parentheses. Remove these parentheses.
So then it would be minus 3,000 plus D.
Minus 3,000 minus C.
Oh.
In other words, this minus applies to both these terms because of the parentheses. It has to be distributed to every term that's inside the parentheses. And that's a huge aspect to the ACT test, because you're going to get a lot of questions like this, where they have a minus sign in front of a parentheses that has multiple terms in it. And since the first step is to remove the parentheses, we have to make sure we don't get the sign wrong. So let's simplify further.
So then that would be 0.904.
No.
Oh, I'm sorry. I'm sorry. That would be 2,100.
Okay.
It would divide.
No. There's no multiplication going on. The only reason we would ever divide is if there was multiplication going on somewhere. There isn't. Yep. What? C equals 200? Okay. Now, the way I would do that is I would move the C to the other side, making it positive, and then I would move the 1900 to the right side, making it 200, like that. If you do it the other way, in other words, if you move the 2100 over to there, you're left with, well, minus 200 on that side equals minus C. Now you have to divide both sides by the minus, and you get 200 equals C. But if you can avoid having a bunch of negative signs, you're better off. In other words, I was able to do it one step quicker by moving the C to the left and the 1900 to the right. Pi? Pi. I don't know what she's upset about, but I think their next door neighbor is painting or something. Sorry, I apologize for the clarity here. Let me write this out so you can read it. We have x to the 7a minus 2 cubed, equals x, just a second, I gotta increase the size of this so that I can read it. X to the 57. What is A?
So this is the distribution of the exponents.
Good. What do we do when we have double exponentiation? In other words, we have something that's being raised to a power and the whole thing's being raised to another power.
You distribute the
Distributed how? What do you use? Multiplication, division, addition, subtraction?
would it be addition?
Nope. Multiplication. Let's go through that before we do this problem. If you have b to the x times b to the y, that's where you add. In other words, if I have 2 to the third times 2 to the fourth, it's 2 to the seventh. Okay? So you're only adding exponents when you're multiplying bases. what if you have b to the x and the whole thing is to the y, like this case? That is equal to b to the xy. In other words, you multiply the exponents when you have double exponentiation going on.
Okay.
In other words, 2 cubed to the 4th equals 2 to the 12th. So simplify the left side of this equation for starters.
So then 7 times 3 would be 21a.
X to the 21a, what else?
Then you do, would it be minus 6?
Uh-huh.
X to the 7?
Now, what can you say? If x to one exponent equals the same x to a different exponent, what must be true? Could this be true?
No.
Exactly. So what must be true here?
The 28.1a could be equal to 7 or no?
Yes, don't be so unconfident.
So you figured that out, so then you'd add 6 to the other side?
Well, yeah, this is easy now. I mean, we don't care. I know you know how to solve this. The key is this concept right here, that if you have a base to one exponent and it equals the same base to a different exponent, then the exponents are equal. They have to be. That's the only way it can work. So I can say 21a minus 6 equals 57, and now solve that. You said add 6 to both sides. Now what?
Divide by 63, which is going to be 0.33.
Hold on. We're solving for a. We're trying to isolate a.
Oh, so then you divide, or you divide 63, or 63 divided by 21.
Okay?
Which is 30. So a equals 30.
That's exactly right. Answer G. Blow this up a little bit. Actually, I can. Let's do it like this. Now, I've covered up the answers purposefully because I want to work through the algebraic solution of this. If 3 times a number, n, is added to 9, the result is negative. Which of the following gives possible values for n? Well, let's take that first sentence and see if we can write an equation or an inequality. What's it going to look like?
So would it be 3n but or 9?
The result is negative. What's that going to mean?
That the answer will be negative?
Okay, so how can I write that as an equation or an inequality? I can't do this. That doesn't have any meaning. I mean, it has meaning, but that's not an equation.
So would it be, could you write equals negative n?
How about less than?
Less than
Less than what?
n?
No, think about it. How does this be negative? What does it have to be less than in order to be negative?
9. Oh, 0.
Right? Negative numbers are less than 0. Positive numbers are greater than 0. If they'd have said it was greater, if they'd have said it was positive, I'd have done that. So when you say something is negative, it's the same as saying it's less than 0. Now, solve that inequality and we're home free. That's an easy inequality to solve.
Okay, so then would you treat the less than sign as equal?
Yes. Yes.
Would it be 3n, or 3n is greater than negative 9?
Why'd you change the sign? That's less than.
Less than a negative 9?
Okay.
So then you divide, so negative 9 divided by 3 is negative 3.
There's your answer.
Okay.
D. Notice not A. D. N has to be less than negative 3. Okay? And that's the best way to do that. We could have potentially back-solved this, but you always want to take the easiest way to solve something. And solving this inequality was really easy. What might have made it a little tougher was if I put a negative sign there. Now solve that inequality.
So then it would be negative 3n less than negative 9, and then you would you divide by negative 3n, so then it would be...
Not by negative 3n. If you divide by negative 3n, you'll be left with 1 on the left side. We want to be left with n. We want to isolate the n.
Divide by negative 3.
Okay. What do we have to do now because we divided by a negative number? Change the sign, the direction of it. In other words, the only difference between solving an inequality and solving an equation is the one caveat is that when you're solving an inequality and you have to divide or multiply by a negative number, you have to switch the direction of the inequality. Since I'm dividing both sides by a negative number, I'm going to get n is now greater than plus 3. That would be the new answer. So they may or may not hit you with that on this test. In other words, they may give you inequalities that don't ever require you to divide by a negative number like this one. We only had to divide by 3. And notice that it doesn't have anything to do with adding or subtracting negative numbers. You only switch the direction if you are dividing or multiplying by a negative number. Either of those cases. Now, this is a pretty common problem. This question is on there twice. We've actually run into it already. If you remember the problem we did that looked kind of like this. They gave us the coordinates here, x comma y, and they gave us this, x comma y, and they wanted the coordinates there. Well, this problem is exactly the same. It's giving us a line, it's giving us the coordinates of one end point of the line, and it's giving us the coordinates of the midpoint of the line. So, just for starters, just for clarification, it's always, if you're completely lost on a problem, you can't go wrong by graphing it. There's one point. That's minus 5 comma 3. And I don't need to graph it exactly. I just need to approximate it so that I can picture it in my mind. Okay? Well, here's the other end. That's the midpoint. 9 comma minus 1. So that makes up a long line. There's one endpoint. There's the midpoint. What's the other endpoint? There.
The difference between the two?
We know the midpoint splits the x's in half, and it splits the y's in half. So whatever our x and y coordinate are up there, we know that this is the middle point. In other words, 9 is the middle point between minus 5 and whatever this value is. Well, let's put it on a number line. There's minus 5. There's 9. If that's the midpoint between minus 5 and some point that's to the right of 9, what is that point?
Like between.
How far is it? How far is it from minus 5 to 9?
4.
Does it look like 4?
Well, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4.
Okay, when I say what's the distance between minus 5 and 9, it means this distance right here. Well, I got to go 5 units to get to there. I got to go 9 more to get to there. So that would be 5 and 9. 14 units. Seeing that is critical, that you can see that it's 14 units between those two. Well, the other way to get that distance is, how about we subtract the big number minus the small number? That's equal to 14. Okay? So this process right here, when you take a positive number and subtract a negative number, is the process of finding the distance between a positive number and a negative number. That's what you do, is you subtract the two. But we don't need to know the algebra of it. We don't need to know that 9 minus a minus 5 is the same as 9 plus 5. We need to just look at it. It's 5 between minus 5 and 0, and it's 9 there, and there's no overlap. So the distance from here to here has to be 14.
Okay.
So what is x?
Would it be 14 more?
Yes. Yes. What is that?
That would be 23.
Yes. What's our answer?
23 negative 5J.
Notice we didn't have to go through the math on the y-coordinate because they were kind enough to put only one 23x coordinate on there as an answer. And that's very common on the ACT. In fact, both problems in this test that are exactly the same do exactly the same thing. They give you 5 answers and only one of them has the correct x-coordinate. So we didn't have to figure out the y-coordinate. But for practice, tell me how we're going to figure out the y-coordinate.
Okay, so then so that'd be 4.
Good.
So then that would be negative 5.
Well, I've drawn this thing screwed up. This negative 1, this point should have been below the x-axis. Let me just redraw the x-axis and then it'll be right. Make sure you go in the right direction. You're going from a positive number. In fact, I drew this point wrong. It should be up here. In fact, my line should have looked like that. Doesn't matter. Even if my picture is wrong, you can see that we're going from a positive 3 to a negative 1, so we're going down. So we have to go down a further 4 points. So you were right your first time, minus 5. In other words, you just have to be consistent in the direction. I want the absolute distance between that and that, which is 4. That's all I care about. I don't care if it's positive or negative. I know I got to go 4 units to get from 3 to minus 1. I got to go another 4 units to get to the y coordinate. But I got to go in the same direction. Well, the same direction is going down. Like I said, I graphed it wrong. It should have been that. So it would have been easier to see that we're going from 3 minus 1. This would have to be minus 5. Okay? So it's not so much, you don't really care about the signs. You care about, are we going in the consistent direction? When we went from minus 5 to plus 9, we were going to the right. We were going left to right. So I know I have to go further right by 14 more. Well, the y unit is going from plus 3 to minus 1. That's going down. I got to go down 4 more units. Down 4 units from minus 1 is minus 5. All right. All right. Here is a problem that requires this is one of the 2 conic section problems. If you'll remember, there's only 2 formulas you need to know for conic sections. You need to know a circle, and you need to know an ellipse. You don't need to know the other 2, which are parabola and hyperbola. You only need to know circles and ellipses. What is the general equation for a circle? And the only way to do this is to memorize it.
For the area?
No. The general equation for a circle. Not for the area, not for the circumference, but the function that is a circle. Plus what? Now let's make sure you know what each of these mean. What is H and K?
Would that be the points on the circle, or?
That is the center of the circle.
Oh.
In other words, if my center of my circle is at 2, 3, then H is 2, K is 3, and my equation of the circle would be x minus 2 squared plus y minus 3 squared. What is R?
The radius.
That's all you need to know. So, in other words, H and K are that's the x-coordinate of the center, that's the y-coordinate of the center, that's the radius. So in this equation that they've given us, the only thing they ask about is what is the radius? Well, we can recognize that we're looking at the equation of a circle, right?
Right.
What's R?
25.
Look again.
Oh. Would it be 5?
Yes. Okay? In other words, when you're looking at the equation of a circle, you're never looking at R. You're always looking at R squared.
Okay.
What's the center of this circle?
-3, or, yeah, -3.
No.
Oh, it would be 3, 3, 4.
Yes, 3, 4. In other words, if I wanted to graph this function, this is, actually it's not a function, excuse me, it's called a relation. It's not a function because it doesn't pass the vertical line test. But if I put 3, 4 right there, and I draw a circle of radius 5 about it, looks like that. that's length 5. In other words, this function or relation is enough to define this circle and its location on the xy coordinate axis. It's precisely its center. The only important thing about a circle is where is it centered and what is its radius. That answers everything there is to know about a circle in the xy plane. Now, notice why that's not a function. Doesn't pass the vertical line test. Vertical line test goes through that point and that point. So a circle is not actually a function. It's a relation. Same thing with an ellipse. An ellipse looks like a circle, only it looks like that. And real quickly, give me the equation of an ellipse. Similar. It's not totally different. It's actually quite similar. It's always got a 1 over there, and it's got 2 other variables. It doesn't have a radius. There is no radius for an ellipse, but there's a minor radius and a major radius. In other words, when I draw an ellipse like that, I got this is A and this is B. And there's your general equation of an ellipse. Memorize it. If you don't memorize it, you're going to get both of those questions wrong. If you memorize both these formulas you're looking at, you should get both of them right. They're that easy. So all you need to know is the general equation and you're going to get it right. Okay? So either write these down or do something and work on memorizing them before you take this test. 2 questions are going to make a substantial difference in your grade. So, or your score. So it's definitely worth memorizing those 2. All right, we got through 29. When are we going to meet again next?
What about next Thursday?
Okay. Instead of Monday?
Yeah.
I'll take this.
Yes. Yep.
I'll take this Monday appointment that was on the 14th, and I'll move it to Thursday, same time.
Okay.
On the 17th. That might be the last session we have, huh? Because you take the test the following Wednesday.
Maybe we could schedule that next week. That
I have you on Monday the 21st at 4. You want me to leave that there?
Yeah, that'd be great.
Okay, so we'll get 2 more sessions. We'll get next Thursday and then the following Monday.
Okay.
All right? All right, Dominique. Have a good week. I'll talk to you next Thursday. Bye-bye.
All right, you too. Have a great week.
You too. Bye-bye.